Okay, let's make a start. So this is the Kubernetes pipelines workshop. Just want to quickly mention, if you're here for operating the API server, that's it now in a different room. That's in D4, I think. So, but hopefully you're all here for our talk. So, just introductions out of the way quickly. I'm Michael. I work for IBM on the container registry team. I've been involved with maintaining Portieris, which is an open source security project which you'll be using, hopefully, as part of this tutorial. And I've been involved with the Notary project, Docker distribution, and a couple of other projects in that area.
Hello, I'm Sam. I work at ControlPlane. We're a little London-based security, pipelines, delivery, Kubernetes, all those fun keywords startup. And we do a lot of work based on securing pipelines, securing deployments, and supply chain security. So for the demo today, well, not the demo, the workshop, we're going to be running on Katacoda. This has been very kindly set up for us by Ben Hall. This link goes to the Katacoda instances we're using. However, they're taking a while to spin up, so I'm going to move on very quickly, so we only get a few of you on. This link will come back towards the end, so don't worry if you don't get in now. Cool, move on and get started. So we're going to be talking, this is the reason why we're all here, right? We're all here to talk about secure pipelines and supply chain security. And what does that mean? That means we're trying to keep the bad guy with his Haxa laptop out of our secrets, out of our cat picks, the most important thing, and by far, we want them out of our supply chain. We don't want someone to get their code running on our infrastructure, masquerading as our code. And this is what we're going to try and fix in our workshop today. So here is a very busy diagram of how at ControlPlane we try and view the cloud native delivery pipeline. This is a little bit oversimplified. We aren't talking about environments here. We don't worry too much about dependencies, but the big key here is that we've got assurance at every stage that what we're building is secure, it's what we tried to build, and it's what we're going to deploy. So this is things like we're storing metadata, and we're verifying metadata all the way through our pipeline. We're doing image scanning to ensure we aren't accidentally introducing CVEs that someone could then take into our infrastructure. And we've got our dependency packages, we're scanning those as well. So here is the stages of a secure delivery lifecycle. We've got to start with our base image. And we've got to start with trusted base images. We don't want to really start with just any old person's version of Alpine on the Docker Hub. You know, who knows what they've done with that. We've got to make sure that our code here is built by the developers we want it to be built by. So we protect against internal threats and someone masquerading as a developer. We then make sure that we're building on trusted infrastructure in a trusted pipeline to ensure that the steps we're taking to build our code are the steps we need. And then, of course, got our application image. This is by far the most important piece of the puzzle here, because if we're sure of our application image, then we're putting a stamp on that. We're saying, this is us. This is our piece. So by default, we're giving it a level of trust that we need to be very, very careful with. Because we're putting this into our infrastructure, we're giving it network routes to our databases, say, we're giving it network routes back to maybe our build server. And then finally, we deploy. And we want to make sure that we're deploying to the correct environment so we don't end up with test code ending up in prod. Because that never happens. So as I'm sure you're aware that security sometimes takes a backseat, especially in a very fast, agile team. We accept risk when maybe we shouldn't. And we're going to recommend you put all of these parts into your pipeline to try and mitigate against that. We're only doing a very short tutorial today. It's only an hour, hour and a half. So this means that we aren't actually going to be building the pipeline. We're going to be doing most of these steps manually. What we're trying to do is introduce you to the tools you can add to your pipeline, introduce you to the ways of working that you can use to put security into your pipeline and secure your code. So yeah, here's our pipeline. You start, you build, and then we've got all of these stop stages where something changes. But pipelines are a fundamental way of building these days. As I'm sure you're aware, it allows us to repeatably do the same steps and verify those steps. And the minimum viable security for one of these is knowledge of exactly what's going through, what CVEs do you have. Are you deploying the code you want to build? So here are various tools we're using at various stages today. Obviously, we're using Docker. Everyone's using Docker. We aren't using all of these, but these are various tools you can use. We've got Hough, Notary. We will be using Notary. In the build stage, you use Graphias for storing metadata, and then you've got images where you can scan your images with Claire, Aqua Micro Scanner. And then at the deploy stage, we're using Kubernetes, obviously, kubesec.io, which is a ControlPlane product, Portieris from IBM, and then again, Graphias when we pull in the metadata. So here are the ones we're using today. Hough, Notary, Claire, Portieris, and kubesec, as well as Docker, obviously. So yeah, here's our build flow. These are the steps we're going to kind of be emulating manually for now, because as I said, doing a full pipeline in a workshop is a lot of work if you aren't going to then move on to other bits. So we're building our image. We're asserting the absence of vulnerabilities. We're signing it for later verification, so we're using Docker Content Trust. We're pushing to a trusted registry, attempting to deploy that to a cluster, and then in the cluster we're verifying that it is the image we want, that the image is secure, that the image is not going to harm our other workloads, and then reject it if the process or organizational policy has been violated. So yeah, like I said, here are the main tools that we're using as part of Harbor. So we've got a Docker distribution for our container registry. We've got Notary and Hough for our cryptographic signing with Docker Content Trust, and then Claire for our image scanning. We will use all of these tools in the workshop. You'll have at least a little exercise on all of them. And so, as I said, we're using Harbor as our complete package for a lot of these tools. It's a self-hosted registry, like JFrog, Nexus. It includes a few other tools and services that you may not get from those registries. It's a CNCF project, and we run it inside Kubernetes for this demo, so it can inspect containers in the actual Kubernetes. There we go. I'll hand it over to Michael.
Just as the clicker stops working, of course. So images aren't immune to exploits. An image is a point in time of what people build, but things become vulnerable. CVEs appear, and you need to be sure when you're shipping stuff to production that those CVEs either don't affect you or straight up aren't present in your image. The process of doing that is something that can't really be done by hand because there's such nuance. With Docker, you've got layers upon layers upon layers of content, that some of which you manage, some of which you don't. And so knowing what's in your image isn't something that is a manual problem to solve. It's something that you're going to need to use automation to do. So it's something that you should be doing in your CI/CD pipeline so that you can be sure what you're running in production. And the clicker's died. So this is what I think of when I visualize images pulled straight from Docker Hub and run on Kubernetes. You have no idea what you're getting and what is going to come out of the woodwork and get you. So we're going to have to inspect each one of these things, and otherwise we might be shipping with CVEs or bits of vulnerable code. And if we don't do that, then each of those CVEs represents a potential attack surface for our application. And I've just been talking about known vulnerabilities. There are things that appear over time, and so we need continuous scanning, and that scanning needs to look deep into our app and see all of the components that we've got. Some scanners look at package versions, some will tell you what layer they're in. The tool that we're going to use, called Claire, will show you which layer your vulnerabilities are in, which is really handy. So some tools look at OS packages, some tools look at application manifests and show you which versions of libraries you're using. Claire is one that looks at OS distro packages, and that's one of the things that we're focusing on. But you do still have to be aware that vulnerabilities in the packages that you import in your code may also have CVEs. So the three most widely used vuln scanners are CoreOS Claire, Acro Microscanner, and Anchor open source engine, although I have to give a plug for IBM's excellent vulnerability scanner, since I work on it. So none of those are standalone projects. They're owned with companies with other offerings in this space, and they combine together to make a final solution. Final solution, that's a terrible thing to say. So Claire creates a list of images and all of the features in them. Features is a keyword. If you're not familiar with that term, they use features to mean like OS versions, package versions, identifying features of the image. And then they compare that against a database to see what vulnerabilities they know of, and they come out at the end with a final result. Microscanner runs a little bit differently because it runs part of a container image that executes in your Docker file. So while you're building the image, Microscanner will run and it will produce a result showing what vulnerabilities you have in the image at that particular point in time, and at that particular point in your image as well. That makes it easy to include as a step in your CI/CD pipeline, but it also means that anything you run after that can expose vulnerabilities. And Anchor is a platform that includes a database of vulnerability information. That runs as a separate container in your infrastructure and creates a searchable list of all your packages. So these apps work in very different ways and give you slightly different results. And that's vulnerability scanning. But you need to also be able to trust that the code that you are intending to put to production is the code that actually goes to production when you press the button. Notary provides that ability to protect what you actually want to deploy. It does that by cryptographic signing. So in the same sense that you would sign some information that you're sending over your network, you sign your images to prove that that content came from you. Digital signatures can be confirmed by a machine, as they are in normal flows. And so we can automate that process in your pipeline so that we can ensure that those images are signed correctly. Notary runs as a service external to your CI. So it's a completely separate thing to manage, but it does provide helpful stuff. And multiple people can provide signatures to the same image. It's one of the benefits of Notary. So we can do stuff like making sure that each person in a list has signed something, and you can use that signature as a sort of approval to that thing going to production. And once it's signed by all of the people that you want in your list, then you can allow it to go. Or we can just use the fact that it's signed to confirm that it came from the correct publisher. So in a normal Docker registry flow, the Docker client in blue on the left asks the registry for a version, it's known as a content digest for the image at a particular tag, so Ubuntu latest. That digest will come back to the client. That client will then go and request all of the data that's inside that image. All of that has gone to the registry, and that provides an attack surface on the registry of anyone with access to the registry can change that 1, 2, 3, 4, 5 in the top corner, which would mean that the client would then go and request different stuff from the registry. Registry provides identity and authorization, but once some data is in the registry, you don't know that the person that actually put that data there is the person that you think it is. By adding Notary into the flow, you go and ask who has proven that that data is the correct stuff. So in this case, because the image is signed by 3 different people and I trust one of them, the Docker client can then go and ask the registry directly for that content. Because of this, we can prove that the stuff that we get out of the registry, and because the 1, 2, 3, 4, 5 actually isn't just a 1, 2, 3, 4, 5, it's a SHA-256 hash, that stuff we can prove is the stuff that was initially intended by that person. So how do we apply Notary to Kubernetes? So we can use an admission controller. We can implement this in the registry flow, but that limits our flexibility somewhat. If we use an admission controller in Kubernetes, we can run some code that when I deploy something to my Kubernetes cluster, it basically makes a decision as to whether something should be allowed to be deployed, it should be blocked, or it should be modified before it's allowed to proceed and be scheduled onto a worker. That means with an admission controller, you can intercept, block, or even change things before they end up onto your cluster. And you can use that for things like verifying an image has been correctly scanned by your vulnerability scanner, or for implementing Notary. Portieris is an admission controller that implements Notary. So switching Docker Content Trust on is an option, but it requires us to have control of our Docker daemons. In the IBM Kubernetes service, we try to avoid giving you SSH access to your workers, and we very strongly recommend against doing that, because if we can stay in the Kubernetes world, that makes things a lot easier to manage, a lot more scalable, and things like that. So the lack of trust pinning is another issue. So we implement in Portieris verification of a particular signer if that's something that you need as well, which is easier to implement in our own code than it is in Notary itself. So Portieris is a mutation admission controller, which means that it can change the data that comes in from the original deployment request into something once we have verified the signature. So in this flow, we have our Notary server, and a request would come in to the API server saying, please schedule my new deployment. That request will then be sent to Portieris in the form of an admission request. And Portieris will go and ask Notary for the information, for the signature information for that image. It then compares the signature that comes back to the policy that you set in your Portieris configuration, and will send some mutated information back to the API server that then goes onto the kubelet, that then goes and spins up a container somewhere. The thing that we mutate in particular is the image name. So once you've got an image name onto your workers, that image name doesn't quite represent the data. It represents a label for that data at this particular time, but it's not immutable. The thing that is immutable is content digests. As long as SHA-256 remains secure, you can't put malicious data into your registry with the same content hash. And so assuming that we don't have collision vulnerability, then you can guarantee that the contents of the image that you get when you pull that SHA from a registry is the image that you wanted.
So yeah, this is a little bit of a change. We've got another webhook, admission webhook we'll be using in the demo. This one goes out to a ControlPlane thing, KubeSec. And this is a fun little tool where you can post your Kubernetes YAML to the endpoint. Please remove all secrets from it before you do that. We don't want to know about your secrets. And it will give you standard vulnerabilities that you may have introduced, standard weaknesses in your setup for the Kubernetes YAML. And then we've got a webhook that will grade that, give you a score, and then if your score is too low, it won't let your pod into the cluster. So it just enforces a bare minimum level of security on everyone in your cluster, so you don't have people going in, spinning up pods that are privileged. They've mounted the host Docker socket in, they're on the host network, and they're running, SSH with no authentication on port 22. That sort of thing. KubeSec has just been open sourced yesterday, so it's very exciting for us. We've got a nice fancy new logo, so please check it out. It's kubesec.io. And here is an example feedback you'll get from the KubeSec API. We've got why we gave you the score you did, and then your score at the bottom. We've got a score at the top, sorry, -30 because you're privileged. The security context is allowing people to run as non-root. And then we've got, we've not dropped any capabilities on the pod. So a little bit on admission control as a general concept, and then we've only got a couple slides here before we get back to the workshop, and then that will be the rest of it for today. So what we're using is these admission controllers to give us a minimum viable security on all of our deployments in the cluster. We're using Harbor and Claire to ensure that services with high vulnerabilities are not being deployed to our cluster. We're using Portieres to ensure trusted content is in our cluster, and KubeSec to verify that our configuration of those containers is not vulnerable, or at least not obviously misconfigured. We should also be using other Kubernetes native services like pod security policies and network policies. This is not a replacement for good Kubernetes security hygiene. This is an addition to that to verify the supply chain into our cluster is valid. And then once in the cluster, we still need to do the standard Kubernetes things to secure your workloads. We've got a little bit on the threat model. So when you're modeling how someone could compromise your cluster, these are some of the attacks we tried to mitigate. We're mitigating container images with no CVEs, theft of registry credentials. Provided they don't get the signing keys, we can be sure that an arbitrary image has not been uploaded to our registry and ended up in our cluster. There are still some risks that we haven't completely covered with this, such as insider risks. Those are very difficult to protect against, as I'm sure people are aware, given that people inside your company need permissions to do things in your cluster. It's very annoying. And zero-day vulnerabilities, obviously they're very hard to protect against. If we've got a 0-day in one of our application images, our image scanners won't know about it and they won't warn us. So here we go. Here is the Katacoda workshop. Everyone please go to this link. It will give you a Catacoda instance, a dedicated instance for today. This, as it's on Catacoda, it's very easy to just click through the buttons and get through it in a few minutes. You won't learn anything. Please take the time to read the text, to have a look at all of the YAMLs we use, to have a look at the scripts we use, and really get to grips with how we're setting up these clusters. This workshop will be also on the Catacoda free tier after, so you won't get a dedicated instance. It takes a little bit longer to come up and start, but you will be able to retry this workshop if you don't finish, or if you want to just have another go or show other people. We will update the link to the free version that you'll be able to just try anytime afterwards. Do anything else?
No, just enjoy the workshop.
So yeah, please get started. We'll be here answering questions, so just shove your hand up if you need any help. We operate Docker as well, so there's quite a few things happening in the background on those instances. If you get ready to go and a terminal prompt, you're there. Go for it. It's one of the steps.
Doesn't work for you? No. Will it create eventually? Okay.
We're having a few issues that we've got enough machines, but not every particular one. I think it's just because we hit very hard days. KubeCon has always been for category, they get a lot of people in doing their workshops. So we've got some dedicated instances, but I think it's the bit behind that, the category bit that's having a bit of a troubling day.
Which cloud you are using?
Using Catecoda. So it's all his.
If you guys haven't quite finished, the slides and the steps will be available after the session at the same link, at the same short link. We'll just change the short link to the slightly different Catecoda place where we'll actually be putting the steps longer term. So, in summary, vulnerable images are, well, not particularly great for our clusters. So CVEs in packages and apps are a real threat to your environment, and you need to be sure that what goes into your environments stays secure. What you've just gone through, you will have seen, hopefully, that you can use your pipeline to make sure that stuff that goes through into your production environments doesn't actually have any vulnerabilities in it at the point where you deploy. Of course, you should always be making sure that that remains the case. And so continuously checking for CVEs is critical. So most of the attacks that occur in the wild aren't just drive-by attacks, people who are looking for deployments with your known vulnerabilities. People are looking at your stuff and going, here's a list of vulnerabilities. Can I actually exploit these vulnerabilities in order to break into someone's system? So as a result, patching and a good patching strategy is absolutely critical, no matter how boring that may seem. And so that's what really helps protect you against potential attacks. And then scanning for vulnerabilities is great. That's one part of the security story. But that only makes sense if you know what it is that's actually in your clusters. So vulnerability scanning in itself is not enough. And so we need to make sure that the image content that we're running is what we say it is. And to make sure that we can't compromise a cluster by pushing stuff into it that we didn't actually intend was going to be there. And so that's everything we've got on our slides. Feel free to ask us any questions if you've got any. If I go, oh no, that's on the Catecoda slides. On the intro to the Catecoda, we've got some links to places where you can get hold of us and ask us questions if you've got stuff after the session. Otherwise, thank you very much.